Good morning. Good morning. Ethan, do you ever have a bad hair day?
Are you making fun of my hair right now?
Oh, it's perfect. I'm giving you,
Yeah. Do you have a bad hair day ever?
I need not anymore, I don't. Yeah, not anymore. My wife's a little bit nervous about her hair getting long. I might have to cut it.
Buzz cut.
Yeah, I think I kind of like it. I like it when that happens. My son is dating somebody that cuts their hair very, very short. But those actor people, that's okay. Well, we're up to 19, 20. What are we doing on time? It is, I'll wait a couple more minutes. All righty. Alex, you're there, correct?
Yes.
So you asked me some questions, okay? And so, which I watched a AP meeting, a webinar, I guess it's called, for all the AP calculus teachers. And it was an hour. It was really boring except for the last half hour, which people could ask questions. So I have somebody said, well, what can students use on the test? And you can use any calculator online or offline, but they said that no calculator is required because it's basic arithmetic. So you can have a calculator there, but it won't be anything beyond basic arithmetic. They said don't simplify because you don't need to. And when you get the questions, you can print them off if you want, if you have the capability, but it's not necessary. So, like I said before, there are two questions, one that's going to be 25 minutes and one that's going to be 15 minutes. I gave you a free response. This one's a 15-minute one. The one next Thursday is 25 minutes. So they said they'll have a timer on your computer. So what'll happen is you do not need to download anything. You're going to go to their site. We're going to practice that in the coming weeks, so you're comfortable with it. And they said they haven't put that out, but they will help me to help you, if that makes any sense, so you can have access. And everything will be on their part. And they're going to have you type in some stuff to be connected to what their server. Does that make sense? So you'll type in, they'll ask you a series of questions, you'll type them in, and you are connected to their server. Now, this is what's interesting. They said that they're really good at catching people that cheat. They've already caught a student who tried to hack into their system to take the AP physics exam. So they laughed and they said, "You won't believe what capabilities we have." And they wouldn't elaborate, but I think they control your computer, and I think they can see you and hear you. I mean, I'd be paranoid. And they said this, make sure you tell your students that for cheating, you will know immediately if you try to do something that's out of whack. And I don't know what they mean by that. They've already caught a student. If they catch you cheating, you obviously don't get your test scored. And they let the universities and colleges know, so that when you apply there, that will be part of whether you will be admitted or not, because you've cheated on the AP exam. And they've basically kept students out of being able to go to college because of that. So that's what we were told. Otherwise, the calculator, you can have one, but it's not necessary. And I would have one just because all of a sudden 2 times 3 becomes 5, you know, that type of stuff. Especially if there's some fractions, you may be comfortable with fractions and stuff like that. Alex, does that kind of answer your question, or do you need something more specific than that?
Yeah, I think that's good.
Okay. So anyway, that's, and for the very first time, and I think this is part of their making sure it's secure, they'll be sending, I will be able to see what you wrote down. I will be able to see your work. I've never seen that before, and I'll get that sometime in May. Now, I don't know what I'm supposed to do with that, but they had referred to that. Okay, does anybody have any questions at all? You'll get more and more information that comes down the line. I may listen to it again and take some additional notes. And if you have any particular questions, just pass them my way. All righty. So I have a particular problem for you, and I got to figure out where I just put it. Oh, do you guys have any questions on any of the work at all? Anything you've been doing? Any type of question? So what's going to happen next Monday, I'm going to come up with a problem that's going to be I'm going to have one that's going to be a table of values. Today it's going to be related rates. And then on Tuesday, it's going to be about separation of variables, which you may have already forgotten. And so we're going to go through some problems like that. Okay? So I'm trying to hit as much of a span as possible. So here's the problem that I have, and I'll share this screen with you. Again, this is in the folder. You see, I'll get rid of this thing. Do you see this cylinder that's 2 feet in diameter and it has a certain height? Yes? No? Anybody?
Yes.
Okay. Because I don't see you guys, so I don't know. Alrighty. So that's what we have. And here are the directions. It says a cylindrical barrel with a diameter of 2 feet contains collected rainwater as shown in the figure above. The water drains out through a valve, which is not shown at the bottom of the barrel. The rate of change of the height of the water barrel with respect to time is modeled by dH dt equals a negative 1/10 square root of h. Ethan, why is it negative?
Because it's draining.
Yeah, because it's draining. Very good. It's decreasing, correct?
Yeah.
Okay. Where h is measured in feet and t is measured in seconds. And it tells you the volume of a cylinder with radius r and height h is v equals pi r squared h. And so what it wants to know is find the rate of change of the volume in the barrel with respect to time when the height of the water is 4 feet. So it's draining. It was way up here at one time, and somehow it's drained, and it's at 4 feet. And we need to know, I need to know where I put my pen. And we need to know what is the rate at which the volume is changing. Alexis, how are you? Alexis?
Hi, sorry.
Oh, okay, that's all right. Rate of change of volume of the water. Are we going to integrate or take a derivative?
Take the derivative.
You're right. What words indicate to you to take a derivative?
Rate of change.
Rate of change. Perfect. What are we going to take the derivative of?
Give me 1 second. Can somebody actually answer the question?
Oh, okay. So you want me to just grab somebody? Is that what you're saying?
Yes, please. I have to step away.
Okay, Aiden. We're going to take a derivative. What are we going to take the derivative of? Bryn, are you out there?
Yes, I am.
What are we going to take the derivative of?
I think you would take the derivative of the dH over dt.
Okay, that would give me the second derivative, correct?
Yeah.
And it says, find the rate of change of the volume of the water. Does that change anything?
Couldn't you use the volume function then?
Yeah. And so I'm going to write that right here. The volume function is pi r squared h, correct?
Yes.
Okay, super. Now, as you know, you notice I have 3 variables here. I have volume, I have radius, and I have height, correct?
Correct.
So as this amount of water drains, is the volume changing?
Of the cylinder or of the water?
Of the water that's in the cylinder?
Yes.
Yes. Pi doesn't change, correct?
Correct.
Is the radius changing?
No.
No, it's a constant, isn't it? Right? I mean, the radius here, whether it's full or the radius down here, is going to be the same, correct?
Yes.
It's constant. What is that constant?
1.
1. So I can write simply this is pi h, correct?
Yes.
And the height is changing. So I'm going to take the derivative with respect to time, and this is going to become dv dt, Okay, that's the derivative of the volume with respect to time. Here I'm going to have pi. The derivative of h would be 1 times dh dt. Does that look familiar, Bryn?
Yes.
Okay, so we have dv dt. We have pi. And I believe when I was talking to Ethan, he said dh dt was a negative 1/10 square root of h, correct?
Yes.
Okay, so I can put negative 1/10 square root, and we are told in here that the height right here, h, is 4 feet. So what am I going to put into here in the square root?
A 4.
A 4. I'm just rewriting that down. Okay, so dv dt equals square root of 4,
2.
2. Do you want me to simplify, or should we just write it out in a non-simplified manner?
Just write it out.
Okay, a negative 2 pi over 10. How's that sound?
Good.
Okay, what are my units? Remember, it's volume, and it's measured in feet, because the diameter is 2 feet, and the height at that moment is 4 feet. So what's the rate of my changing volume that's decreasing?
Feet per second.
Feet. Now it's volume, correct?
Yes.
Is volume measured in feet?
Not normally.
Not normally. It's feet what?
Cubed.
Cubed. Perfect. There we go. There's our problem. That was A. All right, B. B says when the height of the water is 3 feet, is the rate of change of the height of the water with respect to time increasing or decreasing? Is the rate of change of the height of the water with respect to time increasing or decreasing? When the height of the water is 3 feet. Ryan Moilanen, are you out there?
Yes.
Okay. How does it feel to be kind of sitting in the abyss surfing?
Not bad.
Not bad. Not bad. I have a difficult time being on task. All righty. So what do you think we need to do here?
Plug 3 in for the height and see what the rate of change is.
Okay, and it's the rate of the change increasing or decreasing? Is the rate of change of the height? Well, this is the rate of change, correct?
Mm-hmm.
And we want to know whether, if I put 3 in here and I get a negative answer, that means my height is decreasing, correct?
Yeah.
Right? And it's pretty easy to see when I put a 3 in here, I'm going to get negative. But the question is this increasing or decreasing? Correct? Is the derivative, is the rate of change increasing or decreasing? So aren't I asking if the derivative is increasing or decreasing?
Yeah.
Okay. So what do you think I need to do to show my work on this one?
So you plug 3 in for the height and compare it to the other rate of change to see if it's greater or less.
If it's greater or less. what's the, okay, so do you want me to still plug 3 into here?
I'm not sure.
Okay. It's a tough question, isn't it?
Yeah.
I think, would you agree every time we talk about rate of change, we're talking about the derivative?
Yeah.
So I could replace those words with derivative. So the question is the derivative of the height, which is what this is,
Mm-hmm.
with respect to time, right? Is the derivative increasing or decreasing? Does that help? Or does it make it more complicated by me saying that?
So he's supposed to. What are we comparing it to? If it's increasing or decreasing?
Okay, let me ask you this. In calculus, how do we determine whether anything increases or decrease?
Positive or negative?
What's positive or negative? I agree.
The slope.
Right, so like, let's say the amount of hair on my head, okay? If I had a function that described the amount of hair on my head, what would I do in calculus to determine whether it's increasing or decreasing? The amount of hair on my head.
Do the.
Do the what?
Take
Take the what?
the derivative and.
Take the derivative and plug in a value, correct?
Yeah.
And if that derivative is positive, the amount of hair I have is increasing. If it's negative, the amount of hair I have on my head is decreasing, correct?
Mm-hmm.
You okay with that?
Yeah.
Okay. So now we're throwing a curveball at you. We want to know whether this derivative is increasing or decreasing. So if we want to know whether this derivative is increasing or decreasing, don't we have to take its derivative? Doesn't the second derivative tell us whether this derivative is increasing or decreasing? Does that kind of make sense? So again, the question is the rate of change of the height of the water, which is what this is this function increasing or decreasing when the height is 3? So what we're going to do is we're going to take the second derivative and we're going to get, I got right equals here, a negative 1/20th h to the negative 1/2 power, which is the same as a negative 1/20 times, in the denominator, the square root of h. And now I would put 3 into here. And this is oops, I didn't put 3 into here. Sorry. So since this number is negative, it means that this function is decreasing. Explain my reasoning. Well, the second derivative is negative when h equals 3, indicating that the rate of change of the height of the water is decreasing. Okay, Ryan?
I think Ryan got kicked from the call.
Oh, did I do that accidentally?
I don't know, but he's not here right now.
Okay, all right. Alrighty, let's take a look at C. At t equals 0, the height of the water is 5 feet. Oh, this is the perfect thing. Use separation of variables to find an expression for h in terms of t. Alrighty, so we have dh, I'm going to write it right here. This is going to be dh dt is equal to, and I'm going to write it this way, the square root of h over 10. And I'm going to choose Adam. How you doing, Adam?
Pretty good. How are you?
Good. You remember doing this? These two things we're going to separate. Okay.
Okay.
Remember that?
I
And,
wasn't any good at it, but yeah.
pardon?
I wasn't very good at it, but yeah.
Yeah, well, we're going to get good at it. Okay. That's the whole point of this. Okay. That's an ugly T too, and I apologize. Okay. So how
Okay.
do I get this dt over to here?
We multiply it.
Multiply it. And we're going to eventually integrate. I'm going to integrate the right side, and I'm going to integrate the left side, okay?
Okay.
And this h does not match up with this t, does it?
No.
This h has to be on the dh side,
Right.
okay? So in other words, we're separating them, hence the word separation of variables. So this square root of h has to be removed from this dt. I can leave a constant over here. In fact, having a constant over here is okay, because this is the independent variable. This is going to be the dependent variable, because it says find an expression for h in terms of t. So I want h by itself. Okay, Adam?
Okay.
So how do I get this h over to the left side?
I don't suppose you could just divide the h out.
Yeah, it's going to be 1 over the square root of h. Are you okay with that, dh?
Yeah.
And over here, I'm going to be left with negative 1/10 dt. Can you see that okay?
Yeah, I see it.
Okay. So now we're going to integrate. And what I'm going to do to help us out here, I'm going to write h here with an exponent. You know what exponent it should have?
Negative 1/2.
Perfect. Absolutely perfect. And over here, I'm going to have a negative 1/10 dt. And so now I'm going to integrate. Okay. So what is the antiderivative of h to the negative 1/2 power, Adam?
H to the 1/2. Well, 1/2, negative 1/2 h to the 1/2.
Well, h to the 1/2 is correct, because I'm going to add 1, correct?
Yep.
And then I'm either going to divide by 1/2 or multiply by the reciprocal of 1/2,
Which is 2.
2. Now, then Adam, I always check here. 1/2 times 2, that's 1. Subtract 1, I get negative 1/2. Everything's okay.
Okay.
Okay. Equals what over here?
To the 1, so 2, was it 2/10? Negative 2/10?
I think I get a negative 1/10 t
Oh yeah, I'm going the other way. My bad.
plus c.
Right.
Are we okay with that? Because it's just a constant. If it was 3, it'd be 3t. I wish it was 3, but they didn't choose that. Okay.
Okay.
Okay. Now notice they say here t equals 0. The height of the water is 5. The reason they give that is they want this c to be solved.
Right.
Okay. So this is going to be 2 times the square root of 5, because that's my height, correct?
Right.
Equal to negative 1/10 times 0, because it says when t equals 0, plus c.
Right.
So c is 2 times the square root of 5. Would you agree?
Yes.
All right, so now I have 2 times h to the 1/2 power equals a negative 1/10 t plus 2 square root of 5. Would you agree?
Yes.
All right, now we're not done because it says we're almost done. We've earned a lot of points. This one's probably worth 6 points. First one was probably worth 1, B was probably worth 2, and C is probably worth 6 because there's so much work involved here. How do I get so I just have plain old H here? What's the first thing you want me to do?
Divided by 2.
Divided by 2. So I'm going to have H to the 1/2 equals a negative 1/20
Right.
plus square root of 5.
Yep, because the 2's will cancel out.
Yep. And half of 1/10 is 1/20, correct?
Right.
You know who taught me that? My dad. He says, anytime you want to take half of something, just double the denominator. That way you don't have to think. That's what he told me.
Yeah.
Yep. Alrighty. Now, this is not H. This is the square root of H, correct?
Right.
What do I need to do?
We need to square it.
I just need to square it. So then I'm just going to square this, correct?
Correct.
And I'm not going to do any voodoo math. I'm just going to leave it like that,
All right.
right? I'm not going to expand it. I'm not going to make any mistakes. I'm just going to. Now, a voodooist would get it wrong and say, I have a negative 1/4000 t squared plus 5. And that's not the answer. You don't square these individually. Just put them in parentheses and square it. Okay? So we're
Okay.
going to be talking more about this, Adam, on Tuesday, the separation of variables. Okay?
Okay.
So that was the related rate problems. So that kind of took up our time. So tomorrow, I'm going to be here from 10 to, from 10:15 to 1:45, or well, however longer. I'll have to be done at 11, and you guys can come in with any questions you want. Okay, you can come in and out. Does that sound okay to everybody?
Mm-hmm.
Okay, good. Thank you. And so we'll see everybody tomorrow. All right. Nick, did I answer your question about cheating?
Yeah. I wanted to ask, how are you taking attendance?
When you do work, or I show you you're here, that's how I'm taking attendance.
Okay, thank you.
Yep. So I mean, I know stuff comes up every day. So as long as I see that there's some type of progress made in a positive direction, I don't really worry about attendance. Are you okay with that?
Yeah.
Okay.
All right, thank you.
Yeah. All right.
So
So
the
any questions?
Yeah, just one. So the AP test coordinators, they basically said we could use any calculator.
Yep.
And is that it for just a calculator, right? And a pencil or something like that?
Yeah. I mean, you can use your notes. You can use your book.
Just no humans or the
Just no humans and no
internet and stuff.
Yeah, I think for some they'll know somehow, and I don't know how. I mean, they were so confident, I couldn't believe it.
Okay.
Yeah, and
Yeah.
they said talk to your students afterwards to see how they know. I mean, they said, and we will, if they cheat, their lives will become miserable. I mean, they have to, otherwise colleges won't be giving them credit. So they must have, and they've done this before. So I have no idea. It's beyond my thoughts. But I've had, when I've worked with people like Spectrum or something like that, I have issues with my computer. I've had people come in and start manipulating my computer right away. As soon as I logged on. I don't know how my mouse is moving. I'm not even touching my mouse.
Okay.
They must be able to do that from the other end, and I don't know anything about it. Okay.
Okay.
Yeah.
So,
They didn't give me any details. They just said warn your students. So I wanted to warn you guys. Okay.
okay. I'm just
Alright.
surprised someone actually went on ahead and tried to hack the website.
Yeah. Well, not everybody has the moral fiber that you and I have. Okay. All right. We'll see you tomorrow.
See you tomorrow, Mr. Kruger.
Yep.
Thanks.